Here, if you draw a line across a vesica Pisces, the angle of a pentagon is 36 degrees. If you put 36 degrees into there and 36 degrees into there, then you get this other pentagon. And there's no name for it. I call it the extended pentagon. There's no name because there's no mathematical report about it, because very often people who write about weird things tend to be ahead of the academic fraternity. The angles of the pentagon, this extended pentagon, are 36 degrees, the same as this usual pentagon is 36 degrees. There are two pentagons in existence, and there's no reason why that should exist. And there's no reason why that should exist on the landscape of the Pyrenees in the south of France. It's very close to where the Cathar crusade destroyed something like, I don't know, 1 million people or a few million people, and where the Spanish, not the Spanish Inquisition, the Catholic Inquisition began its tortures up until about 1255. Is it possible that they were destroying anyone who knew about this? Or an extension of what I'm talking about today?
Sorry, Colin, is this the points on the circle there? That's where there are churches.
Yeah.
That's,
every one of these points has a church, and also interesting, you've got the Paris meridian coming down that. Even I find the geometry and the mathematics a little bit hard in this book, so I haven't actually looked at it.
So that's like saying basically when you look at a map of that area of France, you see all these churches kind of scattered what you appear randomly, but then actually if you find the point and you transpose this shape on top of it, that's exactly where the churches are.
It's a couple of fellas who were qualified with the theodolites and trigonometry, and they were looking at this particular area, trying to find out why I think Rennes-le-Château is so important and why this particular area was so important. There's a whole conspiracy theory and what have you around it. I haven't got time to go into it today, as you'll see why. You take this interesting shape from Rennes-le-Château and you drop it into this basic octagonal shape. There's the Earth again. We haven't lost the whole thing. There's the design from Rennes-le-Château with the Vesica Pisces on it. It's determined, its position is determined by how many geometric figures it's got. There's 6, there's 5, there's 4, 3, 2, 0, and we're back in the center. So its position is actually fixed by this pentagon. 5 moons, that circle there is 5 moons across. And the pentagon sitting on it. It looks a bit like an eye, doesn't it? With that sort of lens sort of shape looking outwards on it. If you turn that pentagon upside down, you get some signification very like the Hanged Man in some of the tarot packs, and also the evilization of the god Pan with his horns over his head. If you come back from the 4 onto the triangle, it looks a bit complicated, but it's basically just different geometric figures repeatedly overlaid on top of each other. If you come back 1 from the 4, then you would have a triangle, and then you would have the moon again. Now a triangle and a square in this signification is interesting because it gives you something like the shape of a pyramid. And I'll be coming back to that as well again. If you take the same pentagon and you go to the center of the Vesica Pisces, you draw a line out to the end of this extended pentagon and you make a circle, then this angle here, this angle of arc here, is 126.896 degrees, which isn't very interesting until you times it by 1.44. 1.44 is the same sort of numbers we're looking at. 72 times 2, 144, plus another 72, 216. It's the same group of numbers. When you multiply it by 1.44, you get 182.296, which is exactly half of 1 solar year. the geometrical basis of the clock, possibly. If you point this in any direction, and it's wrong to, it's out by about 1.5 hours in half a year, which is pretty exact. If you point this in any direction, you can, at some point, you can come back here, and you can put a peg there, over 182 point whatever it is days, and just follow the sun as it moves, as it's tracked from June to December, and from December back to June. If you remember the Hanukkah candle, the Hanukkah candlestick that I was talking about, this week, I think, this year, sorry, it's December 22nd, last year it was December 21st, the year before it was December 20th. It hovers around this date of the winter solstice. You can position the same design of the candlestick pointing out in any direction that you wish. You're dividing the year into 16. That's 8 divisions of the year. 8 divisions from June to December. Using this device here, geometric device here. You put this whole thing back into the picture again. There's the Earth again, there's the Sun, here's our theoretical 8-sided here. You put this in here and you can start looking at which are the best circumferences of circles to determine how degrees relate to days. We're talking here about the solution, how degrees relate to days. The actual degrees that we're using was something like 5,184 instead of 360. And you get that simply by multiplying 360 by 1.44. It gives you 518.4. 518.4 is in exact ratio to 25,920 years, which is
Precession cycle.
the precession cycle, so you can also use this to measure precession. And look at this one here, you've got 4 clocks. You can put one in the center as well. You've got 4 clocks in the center, stick one on the outside. What is that starting to look like? A Celtic cross, we might say. The pentagon here is based on 5 moons distance. So this array of days here is actually on 6. So on the area of influence of 6 moons. So 6 moons it is from the center, 6 moons from